Sometimes a technology comes along and it just absolutely revolutionizes things, and that is what we have with RAID. In this nugget, I'd like to just give you an introduction to RAID so that we can dig even deeper in subsequent nuggets. RAID stands for a redundant array of inexpensive or independent disks. Yeah, it was originally inexpensive, and then as technologies began to change and things could become very expensive, think about flash drives today, very expensive compared to mechanical disk drives, it was deemed, well, maybe we should just say independent. Now, this is in contrast to what we used to have in the data center, which was a single large expensive disk or SLED technology. What's the problem here? Well, both performance and protection are lacking. This thing would fail and would have major problems in the data center. This thing would have a lot of I/O requests concurrently, and it would have performance issues. So with RAID, which was originally outlined in a paper in 1987, what you're really trying to do is address both performance and protection. That is ideal. As we're going to see in other nuggets where we dig deeper, we have RAID levels. And we have a RAID level 0. Why 0? Well, 0 was picked as that RAID level for a very explicit purpose. It's to demonstrate there is no protection. RAID level 0, therefore, is all about performance. Now, we absolutely love the concept of protection, and that is because the chance of a disk failure in today's data center is very, very good. Why is that? I mean, hasn't technology improved so that disks are more reliable? What's going on here? Well, yeah, the reliability of the disks is constantly improving, but one of the issues is we have more of them than ever. Remember, in our discussions at CBT Nuggets regarding the performance of disks, we saw how adding disks can dramatically improve performance. So we're adding disks like never before in order to improve performance. When we do that, think about it, we are increasing the likelihood of a disk failure. More disks, more chance of failure. And that's why RAID is so absolutely cherished in the data center and has been since the technology went from theory, an academic theory, to something that we could really implement commonly. Now, it turns out that there's two common ways we can implement RAID today: software and hardware. Now, when you initially look at this, you might think, well, Anthony, I'm aware that hardware is faster than software. This has got to be the way to go. And yes, in many cases it is, but please keep in mind there's always benefits and disadvantages to implementing anything a certain way. So please don't completely discount software RAID. Software RAID does indeed refer to having a software application that we install into an OS in order to pull off the redundant array of inexpensive disk behavior. This does tend to get frowned upon for several reasons. Number one, it oftentimes will not have the performance of a hardware RAID solution. Oftentimes, it is not going to give us the features that we would want that are available in a hardware implementation. By this, I am referring to all of the different fancy levels of RAID. So in a software RAID implementation, you might not get the particular RAID level that you're looking for. And then there's another interesting reason that software RAID can become problematic, and that is dealing with the OS. Think about it. The application or the software that is pulling off the RAID for you is indeed tied closely to the operating system. So what will happen is there'll be this big operating system update, a major OS revision, and that might impact the application. In a worst case scenario, that might have the application no longer run right. So now you got this conundrum of, oh my goodness, I've got to update this OS because of security patches or new functionality I need there, but now I've got a problem on the RAID side. And of course, we could always have the opposite effect. There could be some upgrade of the RAID software that actually requires you upgrade the operating system, or it's not going to work. So those complexities are often frowned upon. So hardware RAID is implementing the processing in hardware. By the way, from a performance perspective, that's one of the issues here. You've got this processing of all of the RAID stuff consuming CPU cycles from your host. That's one of the reasons why that gets so ugly from a performance standpoint. Now we are dedicating hardware like CPU resources to the RAID implementation, and obviously offloading this from the operating system and from the applications is going to be a good thing. But we have a decision when we go for hardware RAID, and that decision is, do we do it in the host or do we do it in the array? This is certainly going to be less expensive. You can go out and get what is called a RAID controller card, and you can insert it into a host for doing hardware RAID. As a matter of fact, a lot of hosts have this RAID controller card functionality built right into their motherboard when you purchase the host. Woohoo, bonus! I got my RAID built in. But if you're doing this again and again and again in the host throughout your infrastructure, this can become inefficient and relatively ineffective. And that's why it's nice to do an array. Yeah, with an array-based hardware solution, you have these disks. Let's say we have 8 of them. These disks are in an array. There is built into this array the RAID controller functionality. And now this is all offloaded from the hosts, and they're just accessing the data out of this RAID array. And it's a wonderful centralized situation when we go with the array-based hardware RAID implementation. Keep in mind, again, I'm not saying it is inappropriate for you to target host-based hardware RAID in your environment. There are times when that is perfectly appropriate. It's just great that we have options and that we can scale up to more robust solutions when necessary. So if a company came to me and said, Anthony, we need you to implement a very robust RAID solution for our data center, I would say, okay, here's what we're going to do. we are indeed going to invest in what is called a RAID array. And inside that RAID array is going to be a hardware-based RAID controller. So we have a host out here, and that host is going to connect over the network to the RAID array. They're going to hit the RAID controller, and then let's say there is, let's do 12 disks inside this puppy. Puppy being the official term. Okay, so 4 times 3, that's 12. Whew. Okay, now what we can do is we can go ahead and we can, let me grab a different color here. We can go in and we can define groupings of these disks as what are called RAID groups or RAID sets. So there you go. You can see we have RAID set or group. That terminology is used interchangeably. There's RAID set 1 and there's RAID set 2, for instance. In RAID set 1, we have 1, 2, 3, 4, 5, 6 physical disks. And then RAID 2, we have, coincidence, I didn't mean to do it that way, but we have 6 physical disks in the RAID 2 set. Now, one of the things that we love to do with RAID is, in a RAID array situation like this especially, is we like to add some additional disks. So here I've added 3 more disks, and notice these are not part of a particular RAID set or group, and we can use these as what we call hot spares. And these disks are designed to sit here and wait for a failure so that they can be implemented to replace that failed particular disk inside of our RAID array. So when you start looking at this hardware RAID array solutions and you start thinking about hot spares and you realize that we can improve performance with this if we do it right, in addition to providing this wonderful data protection, it really starts to look like storage technology that you would like to take advantage of. So in this nugget, a high-level overview of the redundant array of independent disks. I sure hope you found this nugget informative, and I'd like to thank you for viewing.